Okay, so in this lecture, we're going to look at some applications of equations of lines. And there's two main ones that we actually care about in this class. First off, parallel lines. As far as the definition goes for parallel lines, we'll say two lines are parallel if they have the same slope and different intercepts. Essentially, the idea is, if we look at a graph, if we have two lines with different intercepts, so say one has an intercept here and one has an intercept here, and they have the same slope, if this line has a slope that looks like this, well then this line has to have the same slope, so it would look the same. And now clearly, these two will never touch each other, which we all know means they're parallel. But now we're going to use that definition to actually solve some problems. So, say we have this. Find the equation of a line that is parallel to 2x plus y equals 5, going through 1, -1. So we want to find the equation of a line that's parallel to 2x plus y equals 5, going through the point 1, -1. As far as it goes, keep in mind, for this one, I'm looking for the equation of a line, which means I'm not looking to find x equals to 4 or 12. I'm looking for an equation, so make sure your answer is an equation. And then it says the equation I'm looking for is a line parallel to this line. We just said two lines are parallel if they have the same slope. So if the line I'm looking for is parallel to this line, then it has to have the same slope as this line. So find the slope of this line, and then I'll know the slope of the line I'm looking for. To find the slope of this line, put it in slope-intercept form. Then we can just read it off. Subtract the 2x, and we get y equals -2x plus 5. Now I know the slope of this line is -2, which means that has to be the slope of the line I'm looking for. And now let's see. I know the line I'm looking for has this slope, and I know it has to go through that point. So if I have a point and a slope, well then I can just plug this into point-slope form. So we have y minus y1 equals m times x minus x1, and plug in the point and the slope. The slope is -2, and then I get y minus the y value, which is -1. Y minus -1 becomes y plus 1, equals -2 times x minus the x value, which is 1. And now this line will definitely be parallel to this line because they have the same slope, and it will go through this point because we made sure that point was in it. And there we go. That's our solution. I had mentioned last time on the last video that as far as equations of lines go, I don't care the form of an answer that you give me. If you want to leave it in point-slope form like this, you're good to go, that's fine. If you're used to writing things in slope-intercept form, distribute your -2, bring the 1 over, write it in slope-intercept form, and you're good. I don't really care as long as you can find the equation of a line for me. The next thing we want to look at, we have parallel lines. There's also perpendicular lines. And as far as the definition goes, we will say two lines are perpendicular if they have negative reciprocal slopes. Two lines are perpendicular if they have negative reciprocal slopes. In order to know what that means, we have to know what negative reciprocal means. And essentially the idea is, if you're given a number, say the number 4, if you want to find the negative reciprocal of that, well, let's see. First, take the negative of 4, this is positive, so the negative it will switch the sign, it'll be negative. And then take the reciprocal. The reciprocal of 4 flips it, so 4 becomes 1/4. So we took 4, we flipped the sign, and we took the reciprocal. That's the negative reciprocal. A couple more examples to make sure we're clear. If we had negative 1/2, to find the negative reciprocal, take the sign and flip it. This is negative, so the negative reciprocal will be positive. Take the fraction and flip it. Reciprocal of 1/2 is 2/1. And then one more. Suppose I have 3/5. The negative reciprocal, switch the sign, this is positive, so the negative reciprocal is negative. Flip the fraction. 3/5 becomes 5/3, and there we go. There is actually another trick here you can use. If we look at this, 4/1 times negative 1/4, if you multiply them out, the 4's cancel, and you're left with negative 1. Here, if we multiply these two, the 2's cancel, we're left with negative 1. If we multiply these out, the 3's cancel and the 5's cancel, and I'm left with negative 1. When you multiply a number by its negative reciprocal, that's always true. You will always get negative 1. Which means another way to actually define perpendicular lines is to say they have negative reciprocal slopes, or the product of their slopes is negative 1. Either definition works as long as you understand what it means. As long as you understand what a negative reciprocal is, then you're good to go. But now we just want to solve a problem to make sure we're clear on this. So suppose we say this. Find the equation of a line perpendicular to 2x plus 3y equals 5, going through 1/4. The way to solve this is similar to what we did for parallel lines, because perpendicularity is determined by slopes again, just like parallel lines. So if I want to find the equation of a line perpendicular to this one, I need to find the slope of this one to find the slope of the line I'm looking for. So 2x plus 3y equals 5. Find the slope. Put it in slope-intercept form, solve for y. Subtract the 2x over. We get 3y equals negative 2x plus 5. And then divide the 3. Y equals negative 2/3 x plus 5/3. Which tells me the slope of this line, the coefficient of x, is negative 2/3. And now just be careful. We want a line perpendicular to this line, which means if the slope of this line is negative 2/3, the slope of the line I'm looking for is a negative reciprocal. So what's the negative reciprocal of negative 2/3? Flip the sign, that's negative, so I want a positive. Flip the fraction, 3/2. If you want to check yourself, 3/2 times negative 2/3. The 3's cancel, the 2's cancel, you're left with negative 1. So it works. But now we can do exactly what we did before with parallel lines. We want a line with this slope going through that point. So use point-slope form. Y minus y1 equals m times x minus x1. So we get y minus the y value 4 equals m, which is 3/2, times x minus the x value, which is 1. And there we go. This line and this line have negative reciprocal slopes, so they'll be perpendicular. And this line definitely goes through that point, because I made sure to put it on there. And we're done. One thing to keep in mind as you're solving these problems, the method of solution is the exact same for perpendicular lines and parallel lines. They're both based off of slope. So find the slope of this line by putting it into slope-intercept form. And then from there, well, you're given a point, so point-slope form. The only thing that really changes is here we wanted a perpendicular line, so we found the negative reciprocal. If we did the same problem but wanted parallel lines, all the math would be the same, but we would actually use this slope because parallel means the same slope. So we would get y minus the y value 4 equals negative 2/3 times x minus 1, the x value. And there we go. So don't think you have to create anything new or make this more complicated than it is. Method of solution is always the same. Put it in a slope-intercept form to find the slope. If you want parallel lines, use the same slope. If you want perpendicular lines, use the negative reciprocal slope. Then use point-slope form with the point and the slope you have, and you're good to go.